This presentation has been created to help us look at how the effects of geology and climate affect the Holderness coast. We will examine which of these factors is the most influential in causing coastal erosion with this presentation. We have here a few key terms on the screen set out as revision cards. They're based on the key terms in the presentation title. The first key word is geology. Do you know what that word means? The geology is the study of materials that make up Earth. The main element of this is the study of rocks. They play an important part in the rates of coastal erosion around the country and especially along the Holderness coast. The other key word is climate. Do you know what this word means? Climate is the average expected weather conditions of the atmosphere. It is based upon results gathered up over at least the last 30 years studying the weather in that particular area. Climate also plays a part with the weathering of the coastline, both in terms of chemical weathering and freeze-thaw weathering. The weather also plays a big part in terms of the strength and size of the waves, which are powered by the wind. Pause the show and make sure you know what each term means before moving on. This distinctive UK landscape stretches 85 kilometres. It's located in East Yorkshire by the North Sea, stretching from the slowly eroding chalk headland of Flamborough Head right down south towards the unique Spurn Point Spit. Coastal erosion is nothing new here, with over 23 villages lost to the sea since the Roman times, when the coast was a further 5 kilometres out to sea. Pause the show and make sure you know how to locate the Holderness coastline before moving on. The geology of the Holderness coast is the most important reason why it's eroding away so quickly. The Holderness coast is surrounded inland by chalk, stretching from Flamborough Head in the far north, along the Yorkshire Wold Hills as an arc, down to the River Humber. The chalk is more resistant to erosion and will only slowly erode. Most of the Holderness coast, though, is made up of very soft sedimentary boulder clays, which have been deposited and built up at the end of the last ice age 18,000 years ago. Since then, they have been rapidly eroding up to 1.8 metres a year. The cliffs only have narrow beaches, so the North Sea regularly reaches the cliff base at high tide and gets scoured away. The soft clays have a very low tensile strength because they're not really bound together very well and therefore can easily be broken apart. Within the boulder clay, though, you do find large rocks known as boulders. These boulders, when exposed to the sea, are used as part of the abrasion process during storms at high tide by being bashed into the cliff and speeding up its erosion. Pause the show now and make note on the important role geology plays with the rapidly eroding Holderness coastline before moving on. The morphology or shape of the coast plays a big part because of its geology. The photograph shows the low-lying slumped clay cliffs and very narrow sandy beaches. The natural Holderness beaches are very steep out towards the sea, which means that the power of the incoming destructive waves are a lot stronger, with them breaking much closer to the coastline. Pause the show and ensure you know about these factors eroding the Holderness coastline before moving on. The rain shadow effect can be found on the Holderness coast. Do you remember what a rain shadow effect is? The Holderness coast is actually protected a lot from the westerly winds due to the Pennines and the Yorkshire Wold Hills, reducing the effects of the prevailing rain-bearing winds. This means that the area of Holderness has relatively low rainfall, with cool summers and mild winters. This means that the actual impact of the climate is further reduced in this region. Pause the show, make sure you know how the rain shadow affects the coastline here before moving on. The climate does, however, impact the size of the waves along the Holderness coast in a few ways. Firstly, the fetch across the North Sea from Norway is up to 800 kilometres long. This means that the erosive power of the waves upon these clear cliffs is very strong during winter storms when the waves further erode the base of the cliff. The waves are mainly fetch-driven winds along this stretch of the coast. The Holderness coast also has a localised climate. This is caused by the difference in temperature between the land and sea. This is because the land heats up and cools down much quicker than the nearby sea. This means that the land cools down more than the sea. This creates offshore winds due to the air moving from cold, high pressure areas over the sea to warm, lower pressure areas over the coast. These offshore winds drive the longshore drift that occurs along this coastline, moving the sediment gradually southwards. Pause the show now and make some notes about the effect of the climate upon the coast before moving on. We can see on the photograph that parts of the edge of the cliff are dropping away and sliding into the sea. This is called slumping. It's due to a combination of factors. During storms, the rain infiltrates the soil through cracks found on the surface. This soaked in water then works its way further into the soil within the cliff, forming a slip plane. Eventually, the broken cliff slab starts to break off from the cliff and slide downwards towards the North Sea. The slump part of the cliff is much weaker and more easily eroded now. The base of the slump part is eroded and then transported away, exposing another part of the cliff. The process then repeats itself, further eroding the Holderness coastline away. This process is really bad to the south of any sea defences, such as those found in Withensea. Pause the show and make sure you know how slumping occurs before moving on. The Holderness coast has always been eroding, however climate change is speeding this process up. General weather patterns are becoming harder to predict, bringing warmer periods that dry out the boulder clay cliffs, causing them to slump even further. Deeper depressions and storms that develop over the North Sea will create larger destructive waves. With stronger onshore winds in these storms, they will have much greater erosive power in the future, scouring the base of the cliffs at high tide and further eroding the cliffs away. Climate change is also directly affecting the North Sea. As the sea absorbs more solar energy, it starts to warm up, causing it to grow and expand. This causes the height of the sea level to rise, which means that at high tide, the sea will be able to cross the narrow sandy beaches and erode higher up the base of the cliff through mainly abrasion and hydraulic action. This will lead to more of the cliffs being eroded away each year. Pause the show and note down how climate change is also a factor behind the rate of erosion on the Holderness coast. We have here on the screen a potential exam question based upon this presentation. It's important to try to bug the question, making sure that you complete all parts of the question. I've underlined the key elements. The question basically asks whether climate is more important than geology when it comes to the erosion of the Holderness coast. Because the question says to what extent, it is important that your response includes both geology and climate, but makes it clear that geology is the most important factor here. Why not pause the show for the last time and have a go at this exam question? Remember, a top answer will include some Holderness coast place names, key facts and terminology, as well as giving a weighted response throughout. This now concludes this geography revision show.